All right, number 11. So the first thing we need to do is figure out what do we need to do for solving the problem. So I'm going to kind of do each step as I do each step. So Larry lives in Lebanon. He's going to visit Adrian in Indianapolis. He gets on I-65, drives 25 kilometers north before he realizes he's going in the wrong direction. Turns around and drives 63,000 meters south. What is the distance and the displacement? So the first thing you need to do is you need to draw a diagram. It's worth a half point. It does not need to be complicated. It doesn't need to be complicated. So here's Larry starting in Lebanon. He drives, is it on here? Nope. There we go. He drives 25 kilometers to the north. That is not a 2. There we go. He realizes he went the wrong way. He turns around and drives 63,000 meters south. And on these, I kind of like to label A and B. I find it helpful to kind of have the beginning and the end part. It does not need to be complicated. I spent way more time than I normally would. I bet I could knock this out in 5 seconds normally. Draw an arrow up, write the number, draw an arrow down, write the number. Bam, there's my diagram. It does not need to be complicated. But I do need to see what's happening. I need to be able to look at the picture and say, okay, they know what's going on in this problem. So that's step 1. Step 2 is what you're going to do is called listing the knowns and unknowns. So this is where you write down what you know in the problem and what you're solving for. So I like to start with what am I solving for. So it asks me to solve for distance and displacement. So I'm going to write DIST for distance. And I'm going to write question mark because I don't know what it is. I'm going to write D for displacement. And the reason I'm using just D for displacement is because we're going to use displacement way more often than we use distance. And that I don't know what it is either. So there's my unknowns taken care of. Now I'm going to do the knowns. What do I have in the problem? Well, I have 25 kilometers north and 63,000 meters south. So I'm going to label these as 2 different displacements. And the reason I know they're displacements and non-distances, this is north, this is south. So they got direction. So they have to be a displacement. They can't be a distance. So I'm going to write D1, 25 kilometers to the north. D2, 63,000 meters south. Can anyone see a problem? There's a problem here. William, what's the problem?
They're not the same.
Yeah, they're not in the same unit. We need to have meters for our unit. Here we go. We need distance to be in meters. So I'm going to turn 25,000 kilometers into meters. I remember that there's 1,000 meters, so 10 to the third meters in 1 kilometer. So that means that for every 25, I should have 1,000 meters. So multiply 25,000 by 1,000. 25 by 1,000, and you get 25,000 meters. Again, I mentioned that from here on out, you don't necessarily have to show work on conversions if they're obvious to you. If they're not obvious, then do them just like we did in the last quiz. But if they aren't obvious, if they are obvious, you can just put the number down. And that'll be to each person. It either will or it won't be. It's not like it should be obvious to you. It might be, it might not be. All right, so there we go. Step 1 done, drew the diagram. Step 2 done, we did the knowns and unknowns there. All right, step 3. Step 3 is to set up the equation. So we need to figure out how to solve it. Now, I didn't really give you an equation for distance and displacement, but we did do that already. The way that we did these, so for example, on this one, we added all the numbers together. On this one, we added the numbers up, but we included direction, right? So here's a negative sign that we did. We still did 5 plus 2, but this time we did 5 plus a negative 2, positive 5 plus negative 2. So the way that we're going to do displacement can be that as well. So basically for the distance, we're just going to add them up. So I'm just saying distance 1 plus distance 2. And for displacement, we're just going to add the displacements together. So d1 plus d2. There's another way to find displacement, and that's to figure out how far apart is it between A and B. That might be easier sometimes. It might be harder sometimes. This one, I think, is harder to do that. An example of where it might be easier is if I say, like, I got on at mile marker 17, I drove 100 meters east, then 100 meters west, then back 30 meters, then back 100, and I got off at mile marker whatever. Then you could just subtract the mile markers. You don't have to do all the numbers in between. Sometimes that's easier, sometimes it's not. There you go, step 3, set up the equation. Okay, step 4 is solve. So now we're going to actually plug in my numbers to get an answer. So my distances were 25,000 plus 63,000. Sorry, I'm going kind of curvy on these. Which brings us to our last step, which is get the answer with the unit. So 25,000 plus 63,000 is 88,000. Now I'm going to do the same thing with displacement, but this time I have to include the directions. So it's positive 25,000 plus negative 63,000. If you're wondering why did I make north positive and south negative, because I decided to. It doesn't matter. That's just what I made it. I usually make up positive, down negative, right positive, left negative. It doesn't really matter as long as one's one and one's the other. Also, you don't have to include the plus. I just did it to show you the difference here. Okay? So when we combine those together, positive 25 plus a negative 63, we end up with, my mental math is not great in the morning, so let's make sure I'm not screwing anything up. Good. 38,000. But specifically, negative 38,000. Let's make it so I can actually see that. Negative 38,000. Notice that both of my units include meters. Notice that, yes, it needs to be negative this time because I called south negative. This was negative 63,000. I ended up south, so I need a negative answer for that.